I am Anil Kumar. Welcome to my series on probability. We'll now discuss binomial distribution. Now, when we want to discuss binomial distribution, it is very important to understand what is a Bernoullis trial. So, in any probability experiment, if we're talking about the events to be independent, and when we have fixed number of n trials measured in terms of only two things, and these are success or failure, right? So these are the two outputs in our trials, and these are independent. These being independent really means that the probability of success remains constant, and we'll use the letter P for the probability of success. Now, in any binomial distribution, it is a discrete distribution where each trial is a Bernoullis trial. That means all the events are independent and where the probability of success remains constant, right? So, binomial distribution is a discrete probability distribution of the number of successes in a sequence of n independent Bernoullis trials. Right? So, you have n trials out of which we are interested in how many are success, right? So all trials are independent. They have only two outcomes, which are success or failure. The probability of success will be P in all our cases, and it is same in every trial. Random variable X defines the possible number of successes, right? So when you throw a dice, possible number of successes could be out of getting 1, 2, 3, 4, 5, or 6. So the random variable value X could be one of these six values. And we'll look into see how many times does any one of those values occur, right? So when X equals to R is those values. So consider now the success X and not the order in which it occurs. So this is kind of very important. Order is not important, right? So in our experiment with n trials, we are only looking for the number of successes, not the sequence of successes. Probability of binomial distribution is given by n choose r, p to the power of r times 1 minus p to the power of n minus r, right? So 1 minus p is q, so we could also write this as n choose r times p to the power of r times q to the power of n minus r. Is that clear to you? So that is how we are going to give the probability for a binomial distribution. The expectation for a binomial distribution Ex is n times p. So it's the product of number of trials and the probability of success. So that is what the expectation is. In this video, we'll take up 14 examples which are based on probability, expected value. We'll also consider mean variance. And all these test examples have been discussed in detail. So let's begin with the very first one, which is tossing coin 6 times. A fair coin is tossed 6 times. Determine the probability that exactly two heads occur. So we're looking for an event and we're looking for the probability of heads, right? So the success will be treated as head, right? Is in terms of heads. Now when we say two heads, that means twice we should get heads, right? So determine the probability that exactly two heads occur. Determine the probability of getting all tails. So all tails means there are 6. So we want to look for all tails. So 3 and 3 is 6 tails, correct? That could also be seen as no head. So if we define our success as probability of getting a head, in that case we could also treat example B. No heads means 6 tails in 6 trials. Determine probability of getting at least 4 heads. Now when we say at least 4 heads, That means we could have 4 heads, or we could have 5 heads, or we could have 6 heads. Correct? That is the meaning of at least 4 heads. And D is determine mean number or expected value for the number of heads tossed, right? So for the number of heads, so in general, on average, that is to say, so on average we mean, right? So mean is on average, right? So on average, in 6 trials, how many heads do you expect? That is what the meaning of part D is. So I hope this part is very clear. Now, let's try to see how to solve such a question. So first thing is you have to check whether it is a binomial distribution or not, right? So, so it is a case of binomial distribution as the outcome is success or failure. So you may get a head or you may get a tail. There are only two outputs, and we are considering in this case uh, success is being defined as getting head, right? So, so that is why it is a binomial distribution, right? And probability of success, which is P, is half in all the trials. So what is we are saying success is? Success for us is in this case, as defined earlier also, is getting ahead, right? That is the success. And the probability for getting ahead is half. Okay. So whenever you toss, what is the probability of getting ahead? It is half. And you see, all these events are independent events, and then they are independent events. So because every time this probability, which you'll call as P, is half, remains constant. So that means the events are independent. Correct? So we'll write here. So we have independent events since the probability P of getting head remains constant. Is that clear? Which is constant. So that is kind of important. Now we have this criteria for binomial distribution, and now you can apply the formula which you learned for probability calculation in binomial distribution. Correct? So now in our experiment, what do we need? We need to find the probability of exactly 2 heads, right? Now, probability of getting one head is half, and not getting a head will be 1 minus half, which is also half. And in our case, the number of trials are 6. Now, in any binomial distribution, we are looking into two parameters. One is the number of trials, and the other is the probability of success. So, both are known to us. So, basically, we are trying to find this particular probability of 2 heads in 6 trials, correct? So it will be 6 choose 2 heads out of 6, where probability of getting head is twice, so square that, and not getting head is 4 times, so half, which is q to the power of 4, correct? So what we have done here is applied the probability formula for binomial distribution, which is n choose r, p to the power of r times 1 minus p to the power of n minus r. So 1 minus p is a failure, correct? Which in our case will be also half. So applying this particular formula, we can calculate the value, which comes out to be 0.234, right? So 6 choose 2 times half to the power of 2 times half to the power of 4. So that is how we get the solution for part A. And now let's do part B, which is probability of getting all tails. Now, we have defined success as what? Success is getting heads. So that really means that in case of all tails, we have no heads, right? So in this case, we have the number of heads is 0, right? So all tails means, uh, you can say, let me write down here, all tails means 0 heads. So in our case, the probability of getting all the tails will be x equals to 0, right? So that is got, that's the same thing. no tails, no heads, right? So from the six trials, we have no heads. 6 choose 0, and half to the power of 0, half to the power of 6. And the first one is for success of heads, which is none of them, and the failure is all tails in this particular case. And when you multiply this, you get 0.0156. So 1.56%. Is that clear to you? Now let's see how to get to find the probability of at least four heads, right? So in case of finding the probability for getting at least four heads means what? At least four heads means that we could get four heads, five heads, or six heads, correct? So that is what we could do. So in this case, since we are looking for probability where x value is greater than or equal to 4, so it will be 6 choose 4, half to the power of 4 times half to the power of 2. This is for 4 heads. For 5 heads, you will change the value of r as 5, and then for 6 heads, it will change to 6, and then you can evaluate. You get the answer 0.344. Now, you could also use an alternate method, and that is when we say that we need probability of getting at least four heads, then we can use the complement, right? Which means not, so not zero heads, one head, or two head, or three heads. You get the idea, right? So not these four cases. So that is all another way of doing it. So using that complement, we can say 1 minus probability of x being less than or equal to 3, right? So not one of these, right? That is the same thing. So here I've used the function which you can use using the calculator also. So this is using calculator. So you can calculate. Numbers are very big many times, and of course the probability will be a small number within 0 to 1. Now, in these calculations, calculators have the function which is binom CDF, BINOM CDF. So that gives you a cumulative probability. So in this case, less than equal to 3. You can use this particular function. The parameters will be number of trials and the probability of success, which is half in this case, right? And 3 is the number you are interested in, up to 3. So in this case, the function is binomial CDF, where n value is 6 for our case, p is the probability, and r is how many you are looking into, right? So 0 to that. So that is the value, correct? So that is how you could use the cumulative function to find this value. So 1 minus, and then you get the result, which is this. You could also do as we did in method number 1, finding those values. So 1 minus sum of 0, 1, 2, or 3 heads, correct? So you get your answer. So it is just to give you the variety. Now moving forward, we'll only focus in not using the graphing calculator functions. Is that okay? But this can be used very easily. Now part D is to find the expected value. Let's look into that part. Determine mean number or the expected value for the number of heads tossed, right? So now in this case, whenever you have probability of success, and if you are doing it n number of times, then the product of the probability times the number of times it is being done gives you the expected value. So that really means in this particular case that if you're going to toss this coin 6 times, then out of 6, 3 times you will get head. That is expected, right? So that is what it is. So 3 heads are expected when the coin is tossed 6 times. So I hope with this you understand the basic concept, what and how we can use the probability distribution to answer the questions based on finding the probability for a fixed number or up to that number or beyond that number of successes, right? And we could also use calculator functions to calculate this value. Okay. Now let's take the second example, which is based on probability distribution. The question here is, the car number plates can have four letters followed by four digits. Anil wants the plate number to be ANIL followed by the prime numbers, either 2, 3, 5, or 7. The four possible numbers are allocated randomly. So this is what Anil wants, but he will get randomly some number for the car plate, right? Now, when we're talking about these numbers, then we know the numbers which you could get is from 0 to 9. So that means there are 10 possible numbers, right? Now, in this particular case, interest is in these four prime numbers, and therefore the probability of success will be 4 out of 10. Correct? That is the whole idea. So let's move forward. Part A is find the probability distribution for the number of these prime digits in the plate. B. What is the expected number of prime digits on the number plate? So let's try to answer this. First is it's very important to understand whether it really belongs to binomial distribution or not, right? It is a case of binomial distribution as the outcomes is success or failure. That means those digits which we are looking forward to could be prime or could not be prime. So there are only two possibilities. And we'll call success as being prime number, right? So we have defined probability of success, which is a prime number. In this case, probability of success, we're looking for only the prime number. So that is the probability of success we're looking for, right? So the probability is 4 out of 10 since there are those four prime numbers within the first 10 digits. And these digits are 0 to 9, correct? So 0.4. So once you get the success, we know the failure probability is 1 minus p, which is 0.6 in this particular case. Now, let us see how do we define the random variable x in this particular case. So we're looking for the prime numbers 2, 3, 5, or 7. And we have four places, right? So we have four places to fill. 1, 2, 3, 4. So number of prime numbers could be how many? So we could get either zero number of prime numbers, or we can get 1, 2, 3, or all of them could be prime numbers, right? That is what we're looking for. So the positions are to be filled by the prime numbers. So when Anil is allocated a number plate, then the numbers, the four digits, may or may not have a prime number. That's the whole idea. And may have how many of them are prime numbers. That is what we're looking for, correct? So it could be either zero number of prime numbers or one number of prime number up to four numbers, correct? So that's the whole idea. So now let us see what is probability distribution and how to work with such examples. Now distribution, the word clearly indicates that what how many times could you get no? What is the probability of getting none of these prime numbers, right? What is the probability of getting one of these, or two of these, or three of these? So, since we are talking about discrete values, correct, as shown here, so this is a discrete probability case. Okay. Now, in every trial, getting a prime or not getting a prime. So that means a success or a failure. And probability of getting a prime in our case is 0.4, correct? Now, none of them is prime out of those four. That means 4 choose 0, right? None of them is prime. The probability will be 0.4 to the power of 0, 0.6 to the power of 4, and it's calculated as 0.1296. One of them is a prime number out of these four. 4 choose 1. Okay, so these values are wrong. 4 choose 1. This will be 4 choose 2. This will be 4 choose 3. And this will be 4 choose 4. Correct? Now, and p to the power of, so the formula which has been applied here is the general formula. N choose r, correct? Probability of success to the power of r, and probability of failure to the power of n minus r. So being that formula is being applied to calculate the probability for number of successes is from 4, and then you get these values shown here, right? So those are the values which you get. When we say probability distribution, it means to sketch a graph for the possible outcomes and their probability. So now, only one, it is 0.1296, which is shown right there, correct? So that is how we show it. So this particular graph indicates the probability distribution for the given condition. The numbers written here are the number of prime numbers which are there out of four places, correct? So you could have none of them, one of them, two of them, three of them, or all four of them, right? So these are the four numbers have their distribution, and that is called probability distribution, right? So that graph is known as probability distribution. Now, let's look into the part B. So this was part A, part B being expected number of prime digits. So normally, what do you expect in this particular case? So that will be, you have to multiply the numbers of positions there with the probability of zero point 0.4 in this case. There are four places. So when you multiply, you get 1.6. So on average, there will be 1.6 number of prime numbers in this particular case. So I hope this part is absolutely clear. Correct? So that is how you're going to answer this question. Let's move on and take the next example, which is, we're calling it spotted eggs. Now, Keg Farm supplies eggs in a transparent plastic cartons. 20% of the eggs are spotted. The production line mixes the eggs randomly and packages 12 per box. Part A. Determine the probability that at least 3 spotted eggs are in a given box. And B is determine the expected number of spotted eggs in a box, right? So in this case, we know that the probability of getting a spotted egg is 20%. So P, which is success for us, is 0.2. Failure is 1 minus 0.2, that gives us 0.8, and in a box we are looking for 12 positions, right? Amongst these 12 positions, we will be interested in determining the probability that at least three are spotted. So when we say at least three, that means we are looking for three are spotted, four are spotted, five are spotted, up to they could be 12, right? Because there are 12 positions. So that is the case. Now, in such cases, it is important to do with complement because we have lesser number of cases, right? And therefore, in this case, we are saying that the probability of at least three spotted means not 0, not 1, not 2. So we'll exclude those and get our answer. So using a complementary function. So we'll do like this. So probability when x is greater than or equal to 3 is equal to 1 minus probability when x is less than or equal to 2, right? So that is 0, 1, and 2. So we'll find 1 minus that probability and using our formula, which is n choose r, probability of p times probability of q, and the powers will be r and n minus r. Correct? Substituting the values, use your calculator to calculate the answer. In this particular case, we get about 44%, right? 0.4417. So that is how you could actually do this function. You could also use calculator graphing functions, right? So for that, you can also look into your manual for calculator and find these answers quickly. Okay, so now we've done part A. Let's look into part B, which is determine mean number. So when we say mean number, it means the same thing as expected value for the number of heads tossed. Okay, now not the number of heads in this case. In this case, we are looking for having at least three spotted eggs, right? So that is what we are looking for. So we are looking for spotted eggs, correct? So that is what we are looking for. In this case, when we say expected numbers of spotted eggs, correct. So determine mean number of expected value for the spotted eggs in a box of 12, in a carton of 12, right? Correct. So mean value will be product of n and the probability, which is 0.2 in this case, and we get 2.4 as the answer, right? Almost 2.5 is the average value of x which you can expect in any carton of 12. Correct. Let's take the next example, which is example 4, tossing three coins. What is the probability distribution for getting tails when three fair coins are tossed? As you know, probability for getting heads or tails is half. Success in our case is tails, right? So we have written here that the success in our case is tails, right? Let's be clear about it. So in our case, we'll do success P as half and Q means heads, which is not a success. This probability is a binomial distribution since these are independent events where the probability remains constant. Correct? Now, when you are tossing the coin three times, in that case, how many tails can you get? Well, you could get zero tail, one tail, two tail, or three tails. So based on all this, we can find using our general formula, which is n choose r, probability of success to the power of r, probability of failure to the power of n minus r. Substituting the values, where r is 0, 1, 2, or 3, and p is half, q is half, we can actually find these values. Once you find these values, add them up. Uh, this is your probability distribution, correct? Now, when you're talking about the probability distribution, as we did earlier also, you could also sketch a graph, correct? So you can sketch a graph for this particular function for values for 0, 1, 2, or 3, correct? So we get 0.125. Let's say that is our value for 0.125, and then 0.3 is almost 3 times, right? Let's say that. And then we have again 0.3 for 2, correct? And 0.125, kind of like this, correct? So that becomes our probability distribution graph, which gives us the probability for an event X, where that is the value for our capital X, right? So could be x equals to 0, 1, or 2, or 3. Okay? You can see it's a discrete function as shown here. So that is what probability distribution is. Now part B is to find the expected value. The expected value is the product of number of trials with the probability of each, which is 3 times half or 1.5. So tails is expected 1.5 times on average when three coins are tossed. Correct? Let's take the next example, which is example 5, color of the cars. 10% of the cars in a parking lot are blue. So we are given the probability here, and what we are looking for is success, which is the color blue, right? So blue color car. So you have to treat like this. Then second thing is, what is the probability of success? Lowercase p, which is 10%, right? So when we say 10%, it is 0.10 or 0.1. So immediately we can find what q is. So q will be 1 minus 0.1, which is 0.9, correct? So these values are written here, and we'll see the question and read and answer these questions. So from the very first statement, you get all this, correct? Now it is independent event, and the car color we are interested in blue or not blue. So it is also true or false kind of a thing, success or failure, correct? Part A. What is the probability that 5 cars in a group of 20 are blue? So immediately you get an idea, 5 out of choose. You have to choose from a 20 group, 5 of them, correct? Probability P, which we know what it is, and probability of Q, which we know, and the powers will be 5 and 15, correct? Their sum should always be 20. That does remind you of binomial theorem, where each term has added powers same, right? When the power of 20 in that case. And that also gives you the name of binomial distribution. So many times you can connect these examples with the binomial expansion, correct? That's kind of important to understand. Well, easy case, I wanted to highlight some more new things, but here's a standard formula and the calculations to give you the answer. It comes to almost 3%. Part B is what is the expected number of blue cars in a group of 20? Multiply 20 with its probability and get the answer. From 20, we expect 2 blue cars. Makes sense, 10% of 20 is 2. So that is the expected number of blue cars in a group of 20, right? So I hope the concept is now absolutely clear. So that forms a foundation for you. You kind of get an idea of what is probability distribution, binomial probability distribution, and how do we solve related questions, correct? Now the questions are going to be slightly tricky. Let's look into these questions and try to understand how do we solve these application questions which are based on probability distribution. So in this case, example, let's see. Peter runs a game which consists of 10 cards as shown below, right? That is a game which Peter runs. These are the 10 cards. The cards are shuffled and each player draws one card which is returned to the deck before the next player draws a card. The prize is the amount shown on the face of the card which is drawn. Calculate the expectation of the game, right? So we know there are 10 cards and the prices in dollars are mentioned on each card. They are shuffled, right? And then they are drawn. We need to find in this particular game what Peter gains or loses. Well, it's the customer which gains or loses. Peter is running the business. Okay. Now, so let us see how to deal with this. Now, what is the question here is to find the expected value. That means how much can a person gain, right? So the real question is how much will a player, let's call that, gain on average. So that is called the expected value for this particular game. And we are interested in this expected value. So as we know, the formula for expected value is number times probability of that, correct? So in this particular case, we could gain $1. And what is the probability of getting $1? That is what we could gain. So there are 10 cards. So when you choose, it could be $1, it could be 2, 3, or $5. So probability in this case for 1, as you can see, is 4 out of 10. So it is written as 0.4, correct? Probability for getting $2 will be 2 out of 10, since these are two numbers here, right? For $2, which is 0.2. Probability for getting $3 is 3 out of 10, which is 0.3. And probability for getting $5 is 1 out of 10, which is 0.1. So we are going to multiply these probabilities with the number of cards to get the expected value, correct? That is what is done here. So to find the expected value, 1 times the probability of getting 1, which is 4 out of 10, then 2 times the probability of getting 2, which is 2 over 10, and 3 times 3 out of 10, 5 times 1 out of 10. Adding these values gives us 2.20. So you could earn $2.20 on average while playing this game. You get the idea. Now, based on these games, we do have a fair game or unfair game, right? So, fair game will be called when what you pay is what you expect to gain. You get the idea, correct? But if you pay, let's say, $3 for this game, then definitely you're going to lose, right? Every time on average, you will lose 80 cents. That is the whole concept, correct? So we'll move forward with this concept and answer more questions, correct, later. Let's get back to a different kind of a question now. Example 6 is recovery rate. Recovery rate of a certain viral disease is 25% if 40 are affected by this disease. Then what is the probability that exactly 15 will recover? And part B is what is the expected number of persons to recover, right? So these two questions go hand in hand when we are working with probability distribution questions, right? So first part first, we're saying that The recovery rate is given to us. So success in our case is what? Success is recovery rate, correct? So recovery. So that is what success is. So we have defined success as recovery, and now we say probability for success is 0.25. So for failure it is going to be 1 minus 0.25, which is 0.75, and in our case we have 40 persons affected, right? So n becomes 40. Now we need to find probability that exactly 15. So exactly 15 means from 40 choose 15, right? And probability of choosing one of them is 0.25, 15 of them power 15. So we apply the multiplicative rule, correct? Independent events, that's the concept. And not rest of them do not recover. 0.75 to the power of 25, correct? Total is 40, and we get our answer, which is 0.0282. So that is how we'll answer part A for this particular question. And B, the expected value is how many will actually recover or are expected to recover on average. That is what it is. So that is the product of number of people affected and their recovery rate, which is 25%, means one fourth, right? So one fourth of 40 is 10, and that is how we get the expected value. So the expected number of persons to recover is 10. And I hope now this concept is absolutely clear. So let's go to the next level of questions now, which is again on probability, all on probability. Question number 7 here is the probability of a shooter hitting the target is 80%. How many minimum number of times must the shooter fire so that the probability of hitting the target is once in at least once is 99%, right? So that's the question. Let's try to understand this. It is given to us that the probability of shooter hitting the target is 80%. So when a person shoots, 20% chances are that it is not going to hit the target. 80% are it is going to hit the target. That means we're talking about success or failure. Success here means what? Hitting the target. So the key word for success is hitting the target. So that becomes our success, and the probability given to us is 0.8. Not hitting the target will be 1 minus 0.8, correct? Now what are we interested in? The question is how many minimum number of times must the shooter fire so that the probability of hitting the target at least once is 99%. So that is how many times should you fire in succession so that the it hits the target at least once, right? That is what it is. So let's find this probability. So we are looking for at least once means if you fire 10 times, for example, then at least one shot is correct, right? So that it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. That's the whole idea. And that probability we want to be more than 99%. That is the question, right? So probability for x being greater than equal to 1 is 99%. That is the question. And how many times can he do it? The value of n is to be found in this case. Do you understand? So this is kind of rework. So it involves reverse calculations, right? So we have a binomial distribution case. We are looking for the two cases, but in this case, we are trying to find what n is. Do you get the idea? Well, we know what the probability is. It has to be minimum 99%. That's the whole idea, right? So that is what we are going to look into. So now, probability of greater than equal to 1 means 1 minus probability of not hitting, correct? So without missing, do you understand? Without missing 99% chances we want to know. That is what the question is. So 1 minus n choose 0, 0.8 is the probability of hitting to the power of 0, and 0.2 is not hitting to the power of all n times. So 1 minus complementary function, that should be greater than 99% decimal equivalent 0.99. So this equation has to be solved. Now to solve this equation, which is exponential equation, sometimes you can use logarithms, right? So you may see logarithm. Correct. In this particular case, what I'm trying to do is I'm showing you the solution without logarithms. Correct. So when you simplify this, it comes to 1 minus 0.99 is greater than 0.2 to the power of n, right? So that really means that we can actually solve this. 0. That is the equation to be solved. You can take log both sides and then do it, right? Now, we will do without calculator. So 0.01, see how it has been done. 0.01 is 1 over 100, correct? And zero point 0.2 is 1 over 5. So we converted these decimals to fractions. See how? Yeah, some students are scared of fractions, but fractions really simplify to the power of n. Now, cross multiply kind of, right? These are positive numbers, right? All positive numbers, you could cross multiply. So 5 to the power of n should be greater than 100, right? And we know n is a discrete number. So n is a number which is not a decimal number, it's a whole number, correct? So therefore, if we want 5 to the power of n to be greater than 0, then minimum value of n can only be 3, right? 5 square is 25, 5 cube is 125, and so we get that the shooter should shoot at least 3 times to ensure that the probability of hitting the target is at least 99%, correct? So that is how we are going to solve this question. So I hope that makes sense, right? So probability of shooting is, because that is how we could do. So then only you will get this value greater than the required 99%, correct? Now let's move on and take example 8, which is fairness of game. For $8, a player can roll a pair of dice once. If the player gets a double, he is allowed to choose an envelope from a box containing 4 identical envelopes, which, however, contains different amounts of money. The amounts are $5, $25, $50, and $100. Is this a fair game? Explain. If he played this game 25 times, how much would he expect to win or lose, right? So that's the case. So we have 4 boxes here. You can say like this. Envelopes, I should say, right? So first thing is, the player is paying $8. So $8 is the cost of the game. We need to find what is the earnings. That is the whole idea, correct? What are the earnings? Now, in each we have a dollar value. So here we have $5, then we have $25 in second envelope, third envelope is $50, and the fourth envelope is $100, right? Okay. So many times we play such games on TV shows also, where behind a gate, what is the prize money? Something like this, correct? Now, in this game, how much can a person gain? So first part over here is that, so a player can roll a pair of dice once. So first thing is you are rolling 2 dice, and if he gets a pair of dice once, the player gets a double. So game starts with dice, and you are rolling it, 2 of them, correct? So you are rolling dice. That is how the game starts. Let's try to understand this game, right? Okay, so when you roll, and if you get a double, only if you get a double, then you can open the envelope. So first condition is get double. Now what does that mean, getting a double? When you roll 2 dice, it really means that both numbers are same. Both numbers are same, That means the numbers are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. Correct? Now, there are 36 combinations, and we are looking for these 6 successes out of 36, which is 1 out of 6. Do you see that? So that is your success rate at this particular case, which we are writing as 1 over 6. Correct? Now, once you are successful, then you have an option to open one of these 4 cards, envelopes, right? So that means each probability is 1/4. You get the idea. Now, when you open these cards, you could get a value which could be $5, which could be $10, which could be 15, 50, or 100. You get the idea, right? As mentioned here. Okay? So these are the dollar values which you could get. Now I hope you have understood the question. I'd like you to pause the video, answer this question, and then look into my suggestions. Correct? Okay, now let's go about it. So a game is fair if the cost of playing the game is equal to the expected return. That's kind of important to understand. So probability of getting a double, as we discussed, is 6 out of 36 or 1 out of 6. And probability of selecting an envelope is 1 out of 4 out of these 4, correct? Expected value is NP, right? So expected value is the product of these two. So we'll multiply 1 by 6 into this 4 and the value 5. Do you get this? And we'll multiply this 1/6 by 4 and this. And we'll multiply this 1/6 with 1/4 and 50. And that is how you're going to find the probability. And so this is what I've written here. Common factor is 1/6 times 1 over 4. And these are the values which are there in the envelope, which are 5, 25, 50, or 100. So when you add them up and multiply by 1 over 24, you get the expected value is $7.50. Correct? So $7.50 is the expected value for this particular game. Correct? Now, second part is, now first part is the game fair? You are paying $8 for this game and you are expecting only 750. Clearly, it is not fair game. You're bound to lose 50 cents per time each time you play the game, right? That is what it is. So in this particular case, if you play the game for 25 times, which is part B, if he plays the game for 25 times, how much will he win or lose? So if you play for 25 times, 25 times the expected loss of 50 cents is what is the answer, correct? So that is what is the expected loss. So 25 times 50 cents is what you lose, right? So we'll redo this calculation. It is 1/4 of uh, I mean you get the idea, right? So that is what you get. So you choose in this particular case, as you can see, that the value here is 1/4 of this 1250, right? So each time you lose 50 cents, so in 25 games you will lose 12.50. So you have a loss for $12.50. So that is the expected loss in this particular game, right? Okay. So that is how you could actually calculate your loss. Correct. So make a correction here. Yeah. So if you play this game, yeah, correct. So let's move forward and take the next example. Example 9. It is based on multiple choice test papers. A multiple choice test has 4 possible answers for each of the 10 questions. So we have 10 questions in all, and then we have multiple choice with each question having, so if we have a question, we have 4 options. Okay, that is what it is, and we have 10 questions. Okay. 50% of the questions should be answered correctly to pass. So we need to answer 5 out of 10 correct answers to pass. Okay. What is the probability of passing if you are certain of 3 of the answers but guess on the others? Oh, so you know 3 correctly, but you need to guess the others. And you know 5 out of 10 should be answered correctly. That means you should get at least 2 correct guesses, right? That is what it is. So now I hope the question is clear. You can pause the video and answer. And let's see, how do we solve it? Now, clearly, when you are making a guesswork, it could be either a correct answer or an incorrect answer, right? So our success is correct answer. That is the success. Now, since there are 4 options, the success rate probability will be 1 out of 4. So p value is 1 out of 4. Q will be 1 minus 1 out of 4, which is 3 out of 4. And how many questions are left to answer? We have to get 2, at least 2 in this case, out of 7 to answer and pass. You get the idea. So that is what we are looking into. We are looking into probability of answering at least 2 out of 7. Then only we can pass, right? So at least 2. It means we can do complementary, which is 1 minus losing 1 and losing 0. None of them, right? So you get either all of them correct or up to 2, right? So, so that is faster to work with. So we'll use complementary. So greater than equal to 2 means 1 minus not getting none of them, right? 0 and not getting 1. So that is what it is. So from 7 we choose 0 to be correct, and so 1 over 4 to the power of 0, 3 over 4 to the power of 7 incorrect, right? And then we also take the case when all are all are incorrect, or 1 is correct, right? Those we'll take away from this probability and find the answer. Calculating, we get the answer as 0.555, which is 55.5% chances, since there are only 4 options, correct? So you can actually do this question with 5 options. The probability P will change, right? 1 out of 5 it will become, and then recalculate and work it out. So I hope that is kind of understood. So this is a very important test question. I'd like you to really focus on it. Now let's move on. Take the next test question, which is again talking about a game. Anil tosses 2 fair coins. He wins $3 if 2 heads occur and $1 if 1 head occurs. If the game is to be fair, how much should he lose? So in this case, game, let us see whether he loses or gains. He loses if no heads occur. Okay, so that's the game. So if Anil tosses 2 fair coins, so there are 2 fair coins. So that means you could get 2 coins, correct? So probability of getting 2 heads, probability of getting head, probability of getting no heads at all, correct? So 1 head, 1 tail, that could be the case. Or the case could be that you get no heads, means both are tails. These are the conditions, right? So these are the 4 conditions which you come up with. Now the question is that if 2 fair coins and he wins $3 for 2 heads, that results into $3. This results into $1, and that is a loss, correct? Now you have to pay something, and that will be lost. That is what the idea is. So what we could do here is to find the average earning, right? And then we can figure out what could be the fair price. So now the question is, Anil tosses 2 fair coins. He wins $3 if 2 heads occur and $1 if 1 head occurs. If the game is to be fair, how much should he lose if no heads occur? All right. So if no heads occur, he's not going to get his money back. So he loses all the money invested. You get the idea, right? So lost. So that is what we are going to check. Correct. So now we can have a probability distribution. So it's again a reverse calculation question for us. So let the loss be of k dollars. We don't know how much, right? So k dollars if no head occurs in tossing 2 fair coins. So let's make a table. So the gain of 3, gain of 1, or loss of k dollars, loss indicated by a negative value. Probability of getting 2 heads is 1 out of 4. Clearly, it is 1 out of these 4. And probability of getting 1 head is 2 out of 4. Probability of getting 2 tails is 1 out of 4. So when we multiply them, we get our earnings expected in this particular case. So 3 into 1 over 4, 1 into 2 over 4 minus k into 1 over 4. And when you add these expected earnings, everything should be 0 since the game is a fair game. Is that clear to you? So that is the idea. So solving, we get k equals to 5. So Anil should lose $5 for not getting ahead if this game is a fair game. Correct? That is how we are going to answer such a question. I hope the concept is absolutely clear. So let's move forward and take the next example. Example 11. A player pays $20 in order to toss 3 coins. So this time we have 3 coins, right? And we have $20 to pay. Okay. The game operator pays the player in dollars 10 times the number of heads. So it is number of heads times 10. That much dollars is being paid, right? So 10 times the number of heads that the player obtains. Determine the mean of the player's net loss. Okay, so we'll again find the expected uh, gain in this. And since we know $20 is being paid, the difference between 20 and the expected gain will be the loss. Correct. So the criteria here is if there are no heads, then you don't get any money back. Correct? 0 times 0 is 0. If you get one head, you get $10, two heads, $20. That means you even out. Correct? So $20 you paid and you even out for $20. If three heads, you get all three, whose probability is 1 out of 8, right? Will be $30. So these are the probabilities of getting one head, two heads, or three heads, correct? So multiplying with the probability, we get the expected value. So that is the question. Since we need to know how much is the loss, we can say, so determine the mean. In this case, we have to determine the mean of the player's net loss, average loss, correct? So average loss minus mean is mu. In our case, that is the mean which we are saying, right? So mu is the mean. Okay, minus the expected value. In this case, we can just add these uh, terms and we get the answer as 15. Clearly, 15 is what we get in this particular case. Since 20 is paid in the game, the mean loss is $5. Correct? That is how we could actually find the answer. So the loss is 20 minus 15, which is equals to $5. So that is how we will actually figure this answer. Right. Example 12. A backyard is to be enclosed with 18-meter of fencing. The length of the backyard is to be an integer length and is to be shown randomly. What is the expected area of the backyard, right? So we are working on the rectangle area basically. We are given the perimeter, correct? So the fencing, let us say, which is enclosing the backyard, we know the perimeter is 18. So think like this. We have a rectangular backyard whose length and width we need to figure out. It is randomly selected. But since the perimeter, which is twice length plus width, is given to us, which is 18, so 18 equals to twice length plus width. Clearly, 18 divided by 2 is the combination of length and width. So 9 could be the sum of length and width, correct? So whatever may be the length or width, the sum of length and width is 9. That is kind of important to understand, correct? So this is one part which you have to figure out. Once you do that, in that case, it is straightforward. So the perimeter is 18. Possible dimensions could be what? We know these are integer values, correct? So the numbers which will give you sum of 9 are the possible dimensions of this rectangular area, right? Backyard in this case. So it could be 8 and 1, right? 7, 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, 7, or 1, 8. All this, when you multiply them together, you get the area of this particular rectangular field. And the question is, what is the expected area of the backyard? Correct? So we'll see what numbers are randomly chosen, what is their probability. We know the area. So the areas to work with are 8, 14, 18, and 20. For 8, we know each values occur 2 times. So 2 out of 8 is the probability of each. You could even write 1 out of 4. Is it okay? So you could also write 1 over 4. That's perfectly fine, right? Now, and then multiply these values, and then what you get is the expected value. So in this particular case, expected value, when you multiply, comes out to be 15. So the expected area is 15 meters square. Perfect. So that is how this question is going to be answered. Clear? Now here is question number 13, which is uh, random variable x has probability distribution P x equals to k equals to ck, right? Very interesting question. It is a thinking question from test paper. Probability x equals to k is ck, where k is equals to 0, 1, 2, 3, 4, and c is any constant. Now the question is to determine the value of c, determine the probability when x is greater than or equal to 2, determine the expected value in this particular case. So now we are given the probability distribution, binomial distribution already, correct? We are given this. Now we need to find the probability and expectation, correct? The formula which is given to us is that probability distribution for x equals to k is ck. Now, substituting the value of k as 0, 1, 2, as 1, 2, 3, and 4, we get the 4 conditions. So that is what has been done here in the table. So when k is equal to 1, in that case, the value probability is c. When k is 2, then it is 2c. 3, 3c, 4, 4c, right? And all these sums should be 1, right? So sum of this should be equal to 1. So when you add them up, what you get is the sum is equals to 1, and you can calculate the value of c. And that is how you could do part A. Is that clear to you? Now, second part is to find the probability when x is greater than or equal to 2. So greater than or equal to 2 means these three cases, correct? So add them up, these three cases. We know the value of c now, which is 1 over 10. Substitute that value and get the answer, which is 0.9. Last case is to find the expected value. Now, we know the value of c, and therefore the expected value will be n into p, right? So n into p is giving you the expected value, which we can now figure out since we have all the values with us. So multiply and add them up, we get the answer, which is 3. So I'd like you to go through this video once again, understand the concept. It is one of the very interesting questions from this particular topic. Last question for us is distribution from mean and variance. So I included this in this particular case since many times you may have to work with the variance and the mean given to you. If mean and variance of a binomial distribution are respectively 9 and 6, find the distribution. That is the question, right? So in this particular case, we know the mean, which is 9, and sigma square, which is 6. We need to find what is this binomial distribution, the values of n and p, correct? So mean is the expected value. So mean, the expected value is n times p, which is equal to 9. So we get one of our equations from that condition. And second is the variance, which is sigma square, the value is npq, which is our second equation. So now, once you know the mean and variance in terms of n, p, and q, then we can actually do some basic algebra to find. So now in this case, we are doing equation 2 divided by equation 1. So in that case, np and np cancels. You find the value of q. Once you know that the value of q is given to us, p is 1 minus q. So we get 1/3 in this particular case. Once we know p, you can always find n. substituting in equation number 1, right? And so you get the value of n, which is 27. And so we know the binomial distribution, which is 27 trials with a success probability of 1/3. So n equals to 27 and p equals to 1 over 3. So that is how this question should be solved. So I hope with this you understand complete concept on binomial distribution. I hope you find it interesting and useful. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.